so the last speaker is me. So I'm not a scientist. I'm a philosopher. So I want to kind of give a kind of brief introduction about the implication of this whole the framework that we have been discussing today. As a philosopher of science, I'm interested in what kind of philosophical implication this model has, and this is a kind of my rough sketch about maybe philosophers, we might be interested in exploring these aspects. So this is kind of suggestion. There's no conclusion, but that's kind of the a suggestion for kind of to stimulate discussion. So this is the contents. So as we have been discussing, this new framework, the CPCMS. So I think that this kind of motivate the transition from the confirmatory to generative view of science, and this has a kind of multifaceted implication on what is scientific objectivity and what counts as scientific progress, and also scientific methodology. So I want to focus on each of these topics in turn. So that's the kind of the agenda of my talk. Okay, so let me start with a traditional view of science, also known as a received view of philosophy of science. Traditionally, well, of course, this is a kind of caricaturist view, but traditionally, philosophers of science have kind of distinguished between the context of discovery and the context of justification, and focused on the latter. So we focus on the context of justification with the idea that what makes scientific hypothesis as a knowledge is characterized not by how the hypothesis is discovered or conceived. For example, we don't care how Einstein or anyone come up with the idea of the relativity theory. So how maybe he discovered that from an analogy to something. Maybe he come up with what during he's reading a novel or anything. We don't care. Because what makes the science is the method of justification. That is, how a hypothesis is justified is important. And okay, so and with this interest, the philosopher of science have focused on what counts as objective evidence and what is a logical reasoning, like we have a hypothetical deductive method and so on, and also the statistical methods like Bayesian statistics and frequent test statistics, which are basically tools to justify hypotheses. So this is what I call the confirmatory view of science, and the goal, and it implies that the goal of science is a kind of accumulation of confirmed hypotheses. So we try to confirm the hypothesis, and if they get confirmed, we get kind of knowledge, and we want to accumulate this knowledge. So that's a kind of goal of science. This is a kind of what I call traditional view. My impression is that the CPCMS kind of challenged this picture. And if what is CPCMS, so we have discussed this day. So I don't think I need to repeat here. But basically, the underlying idea is that science is a collaborative activity where we have agent here, and the agent make an observation by interacting with the external world and update how or has internal representation expressed in terms of a conditional distribution of this, and then write a paper as a sample from this distribution. So it kind of the sample W as a paper or some kind of external communication, the concept. And then a reviewer assess this sampling based on his or her internal representation. And if this the proposal is accepted, this proposal is incorporated into the global posterior distribution, and which we hope approximate the true posterior distribution. And as the first speaker discussed, that this whole process represents the Metroparse-Hastings algorithm for approximating the true posterior distribution P W/O. So that's the overall picture. And so what's the implication of it? So first implications is about scientific objectivity. So here I want to draw the criticisms of the received view by Longino and Kitcher. They criticize the received view as a kind of the how to say that it's not that really represent the actual practice of science. So so they characterize the received view as a kind of as follows. So according to the received view, scientific method is practiced by a single individual or maybe a team of individuals. But anyway, it is a kind of the single entities, and the objectivity is warranted when the individual scientist or maybe research team follow this correct methods. For example, there are several kind of correct scientific method out there. Maybe it's a correct way to correct data or make observation or do experiments and do statistical tests and so on. And there's no kind of interactive component to it. So each practitioner follows strictly to this rule, and then you get objective result. So that's the received view, or that's how they characterize this view. But they criticize this view, and they propose instead the concept of social objectivity. So Rangina says that the objectivity of scientific inquiry is a consequence of this inquiry being a social and not an individual enterprise. This social practice enterprise includes the intersubjective criticism like peer review or replications and so on. And Rangino also stressed that the heterogeneity and diversity of scientific communication, scientific community is important because it enrich the perspectives in the scientific community. So you have a diverse view. And also, she emphasized the situatedness of individual scientists. So individual scientists need not to be unbiased. They might have different motivations, agenda, and biases, but that's fine because during the intersubjective interactions, they get criticized each other, and finally you get the objective outcome. So that's Longino's view. And I think that this line up well is CPCMS view of science. So CPCMS model science, MS can be understood as a kind of model of scientific interactions. So it emphasizes the process of paper writing and review, and after that, incorporation into the posterior distribution. So this part. And it allows for the convergence without consensus. So we finally it says that if we repeat this process, the whole global representation will converge to the true posterior. But it does not mean that each scientist agree with it. A convergence of the posterior can happen even if the individual scientists disagree each other. So they may have a different posterior inner representation. And also, they don't have to have a correct posterior. Each individual may have a kind of the wrong posterior. So in this sense, well, it allows a convergence with consensus. And also, it emphasized the importance of divergence. Excuse me. Because it implies that diversity and openness promote convergence. Because this algorithm, the Metropolis Hastings, is a Bayesian Markov chain Monte Carlo algorithm, the requirement of the convergence of Markov chain is algodicity, which means that, well, very roughly put, which means that the chain gonna explore all possibilities in the long run. So the individual should not be or group or communication of scientific researchers should not stick to one particular hypothesis or one particular area, but there must be various people who explore various possibilities. So that kind of guarantees the ergodicity of the Markov chain and finally promotes the convergence. So in this view, diversity is actually key to the convergence. So that's the first point. And the second point is implications on scientific progress. And this part is already discussed by Hayashi-san, but I'm going to repeat nevertheless. So the progress, according to the received view, is, as I said, the accumulation of comfort knowledge. But this idea faced difficulties in the philosophy of science community. One is a Kuhnian incommensurability between scientific revolutions. So between scientific revolutions, there is no common standard between different paradigms. So we cannot say what kind of differently say which theory has a kind of more truth or something. And also, we have a problem how to say that the new paradigm is better than the old one. And the second problem is this notorious pessimistic induction. So actually, so many scientific theories ended up being refuted, like phlogiston theory and so on. So that means maybe the current best theory, like the relativity theory or quantum mechanics, might be refuted in future. So then we are not accumulating truth after all. We are accumulating the incorrect kind of thing, like the incorrect belief, like the phlogiston and so on. So maybe in the future it can be refuted. So there's no progress. So yeah, that was the problem, and the one possible solution from the CPCMS is that, well, the CPCMS focus shift the focus from knowledge accumulation to the success of prediction. So that is why we call it kind of generative view. Then so yes, and in CPCMS, we do estimate, the scientific community does estimate posterior distribution, but posterior distribution also serves as a means for prediction through posterior predictive distribution. And so this serves to predict the future outcomes. And Bayesian update tend to minimize this predictive loss. So we can think that as a kind of as the research goes, the predictability of scientific community in general become better and better. And this point is what Hayashi-san has discussed to detail. This model may deal with a paradigm shift as well. And actually, it can be a model of paradigm shift themselves, because the singular model can be understood as a kind of the singular models entails discontinuous jumps among singular points, as Hayson explained, and this is a kind of parallel, or this can be kind of model of Kuhnian revolution. So there's each singular point represents a certain kind of paradigm, and the jump represent certain kind of paradigmatic shift. And during the between the paradigmatic shift, it entails a radical change in the representation. So this researchers can no longer discuss, or they can no longer understand what the other said, or how or what the other understand. But the predict performance itself gets better. So we have a certain kind of comparative, comparable kind of standard in terms of predictive loss. So that's the second point. And finally, implication on scientific methodology. According to the received view, scientific methods are kind of an algorithm to truth. So it can be used by each individual scientist. So I can use a statistical, test and so on, and hopefully, well, in the hope that it can bring about objective conclusions of my study, and well, when used properly. But of course, this kind of idea of statistical method and scientific method has grain of truth, but we don't think this is a whole picture. The generative view motivates us to see that scientific method as a kind of communication tools. So scientific methodologies allows us or scientists or researchers to communicate to each other. They give a kind of communication platform. That is how material and the method in the scientific paper is written in order to classify what kind of assumptions and logic are assumed in a certain paper, and that allows a reviewer to kind of assess the content of the paper, right? And also statistics serve this kind of role as well, because it allows peer reviewers to judge the quality of evidence. So, okay, so of course, this is not a very kind of recommended way of using p-value or something, but well, through p-value, we can check, well, the quality of evidence. So it's a kind of the indicator of the what is done by this research and so on. So it serves as a kind of communication language. So CPCMS focusing on this part, emphasize this kind of communicative role of scientific methods. Okay, so yeah, that's about it. So in the conclusions, as an implication of CPCMS, I think we have at least 3 points. One on the scientific objectivity, that is that CPCMS can serve as a model of scientific objectivity, where diversity promotes convergence without consensus. And also, it might lead to the problem of scientific progress, in the sense by taking progress as a kind of improvement in predictive performance, even between different paradigms. And finally, it has some implication on scientific methodology, taking it as a kind of communication tools that facilitate the metropolitan naming game. Okay, that's pretty much it. Well, thank you very much.